Okay, let's look at another example of balancing redox reactions occurring in the acidic medium. So this is an example where iodide ion is reacting with the dichromate ion in the acidic medium, giving you chromium in +3 charge and iodine as a solid. Okay, so what is the first step? The first step is always to assign the oxidation numbers. So we see that iodine is the oxidation numbers of iodine is -1. Okay, let us say we do not know the oxidation number of chromium. So for chromium, you can always put X, and there are two chromiums. So 2X plus 7 times -2 for oxygen is equal to -2. So here this is 2X minus 14 is equal to -2, and 2X is equal to -2 plus 14, and that gives you X is equal to +6 when you balance this whole, when you solve this further. Okay, anyway, so here comes the chromium. The oxidation number of chromium is equal to +3. So generally the oxidation numbers are equal to the charges, okay? So oxidation number of chromium is +3, and the oxidation number of diatomic iodine is 0. So I2 is equal to 0. So let's see what's happening here. Which one is getting oxidized and which one is getting reduced? So we clearly see iodine has gone from -1 to iodine has gone to 0. Okay, and made the oxidation number has gone from -1 to 0. Next is we leave oxygen, but we're going to look at chromium. Chromium has clearly gone from +6 state to a +3 state. So here we have iodine that is getting oxidized, going from negative -1 to a 0 state, its oxidation, and chromium is getting reduced. Okay, so chromium got reduced and iodine got oxidized. So reduced, the entity that got reduced acts as a the entity that got oxidized acts as a reducing agent, and the entity that got reduced acts as the oxidizing agent. So it's always opposite, okay? Oxidizing agent. Okay, so these are the agents, and this one is the agent. All right, now you're going to split it up into two parts, that is the two cells. And so first cell is going to be where iodine is converting to I2. Okay, so we're going to put this on one side, iodine -1 to I2. Okay, so this state is the oxidation cell, and here is the reduction cell, RED, and this is the cell. Okay, so in the reduction cell, we are going to put all of, although we just looked at chromium, but we're going to put all of dichromate, Cr2O7, Cr2O7 -2 has gone from this state to Cr +3 state. Okay, so this is our two cells. Now we are going to balance. So start balancing now. So first balance the chromium, okay, which is non-oxygen and non-hydrogen. So balance chromium. So here you have Cr2O7 -2. So you are going to put 2 here, and this becomes Cr2Cr +3 charge. And iodine, we don't need to touch yet. Okay, next step is you're going to balance the oxygen. So balance the oxygen and balance oxygen. And how do you do that? You're going to add water. Okay, so bring water. So here is your Cr2O7 -2. And on the other side, we need to bring oxygen. So 2Cr +3 is going to stay. And then you are going to add that many oxygens as you see on the left-hand side. So here we will have seven water molecules, because we are not focusing on hydrogen yet. We are focusing on oxygen only. So 7 water molecules bring 7 oxygens. So that balances the oxygens. Now you're going to balance the third one is the balance the hydrogens. Okay, and how do you balance the hydrogens? You're going to bring in the hydrogen ions. Okay, so this, now we have 14 hydrogens. So we are going to add 14, let me add it on the side, sorry, let me add. So we are bringing in 14 hydrogen ions to balance the hydrogens on the right hand side, okay? Plus Cr2O7 minus 2, and this gives you 2 Cr plus 3 plus 7 H2O. Okay? All right, now we are going to balance the charges. Let's look at that. Balance the charges. So here is this thing, and balance the charge. Balance the charge. So how do you do that? Now this can be sometimes a little bit tricky. The way I like to do is this way. Okay, you count the positives and the negative charges and then go from there. So total we see a 14 of plus 1 charge, okay, plus dichromate is one big species by itself, and there's only one dichromate. So there is one dichromate, and that has 2 negative charges. Okay, so I'm going to just put this here. This is coming from the hydrogens plus, and this is coming from the dichromate, Cr2O7 minus 2. Okay, and then 14. So that's what it is. Okay, next is we are going to bring the charges on the other side also, and that is going to be here we will have, now because we need to balance the charges, so that's why I added the equal to sign. Okay, so here we have 6, so in other words 2 plus 3 charges, and that is coming from the chromium, so Cr plus 3, and that's 2. And then there is 7 H2O, and regardless how many H2Os you have, it's a neutral molecule, so it is going to be 0. So this is how you write down the charges first of all, the plus and the negative. Then you count total. So here is your 14 positive, plus this is going to be minus 2, okay, plus minus minus, minus 1 positive multiplied by negative. Okay, anyway, so you know it. So 14 minus 2 is equal to, or if you want to put the other sign, that's fine as well. It doesn't matter. Okay, here is going to be 6 plus 0. Now, 14 minus 2 is 12. And here you have 6. So we will have to, see, that's another thing. There's a mindset. Normally when you're doing the molecular equations, you add on. You see that? You add on you bring in some more coefficient and you increase it. But here we will have to decrease it. So how are we going to do it? We are going to add, if we add 6 electrons here, 6 electron means 6 negative charges, right? So this is minus 1 charges, but minus 6 charges, that's what it means. And plus 12, and that's going to give you, and this is positive, okay, positive 6. Okay, so now with that said, we have positive 6 here, and we have positive 6 here. So this is how we balance the charges. Now, we understand it's positive 6 and positive 6 and all this is great, balanced it, but now we need to bring the third piece, which is the electrons, balancing the electrons. So balance the electrons. And how do you do that? You are going to make it and bring in both the equations now. That's one thing. So let's bring in iodine and then bring it down. So iodine, 1 negative charge, and I'm not putting, as you've seen, I'm not putting AQ. I mean, it's kind of understood that this whole reaction is happening in AQ, and it's just going to occupy space, and I want to keep it clean. This is the reason why I'm not putting AQ, 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 AQ all the time. It's not like, I mean, it's understood this is happening. So I'm not, I need clean space. Okay, so that's why, for that purposes. But you know, just keep that in mind that they're obviously not happening, you know, in some other medium, but it's just aqueous medium. So anyways, let's write this down now. So we have iodine now. So we have iodine, and how many were there? There were 2. Oh, we didn't balance iodine. I'm sorry here. So let's balance it. Okay, so 2 iodine here and I2. Okay, so we are bringing in 2 iodines. That is giving you I2. Okay, that's one thing. And then next we are bringing in is the other piece, which is the 6 electrons that we had added, you know. So 6 electrons on this 14, yeah, 14. So we just bring in 14 hydrogens, ions, 6 electrons were added, plus 14 hydrogen ions, okay, plus the dichromate, Cr2O7 minus 2, okay, and that gives you 2 Cr with a plus T charge, 2 Cr with a plus 3 charge, plus 7H2O. Okay, so bring this whole equation here. Okay, so now we need to also look at the iodine. You balance the iodine. There is, in this case also, we are giving away, the iodine is giving away 2 electrons. Okay, so this is the deal with iodine. It's giving away 2 electrons, so that's balancing. So 2 iodines is giving you I2, but the balance the electrons here, that is why it's becoming that. So now we have to balance the electrons. And how do we make them 6? So in order to do that, we're going to look at the common multiple, which is 3. Okay, so you're going to multiply this whole thing by 3 so that you can get, and I'm going to just write it here now below it, that so that we now can get 6 iodines, okay, and they are going to give you 3 I2 and 6 electrons. Okay, so next is you're going to just cancel out the electrons. So if you look at it, sorry, this would be, let's do it with this. So 6 electrons and 6 electrons cancel out. Okay, and what are we left with? We are left with 6 iodides. Just use it now. 6 iodides plus 14 hydrogen ions, okay, plus dichromate, Cr2O7, 2 negative, okay, and this is giving you 3 iodines plus 2 chromiums, Cr plus 3, plus 7 H2O, okay, 7 H2O. Now let's check. So the last piece is always make sure that you check. Okay, the checking is here, which is the reactants here, reactants and the products. Okay, so in the reactant side, what do we have? We have 6 iodines, we have 14 hydrogens, and then we have 2 chromiums, and then we have 7 oxygens. And look at the charges. Charges are 6 times minus 1, that's coming from iodine, plus 14 times plus 1, that's coming from hydrogens, plus for the chromium dichromate, it's all together, it's all one word, it's all one thing, and that is going to be minus 2. Okay, so 1 multiply by minus 2, and that gives you 3 times iodine is 0, okay, plus 2 times plus 3 charge, plus 7 times 0. So pretty much on this side, it is 0 plus 6 plus 0. Okay, and here you have minus 6 plus 14 minus 2. Okay, so what do you get on this side? 14. So this would be a positive 6 charge, and here is your positive 6 charge. Okay, so that's on the product side also. If you look at it, there are 6 iodines, and there are 14 hydrogens, and there are 2 chromiums, and there are 7 oxygens. Okay, so that balances every single entity in this reaction. And that is your redox reactions balancing by the half cell method. I hope it was easy. Thank you. Take care. Bye.